Let's have an in-depth look into Voxengo TEOTE. We will go into extensive details on how TEOTE works and what it does. Now without any further ado, Voxengo TEOTE. TEOTE is an automatic spectral balancer plugin for professional music production applications. It is a useful tool for both mixing and mastering. It automatically performs such tasks like gentle resonances taming, de-essing, tilt equalizing, usually performed during mixing and mastering. In mixing, TEOTE sounds good on pretty much any material. While by definition TEOTE is a dynamic equalizer, its technology is solely based on multiband dynamics processing. This allows TEOTE to have only minor phase issues, and to produce a subtle transient emphasis effect associated with dynamics processing. TEOTE tries to make the program material follow the specified spectral profile, tuned to the contemporary mastering standards by default. It can be said that TEOTE straightens the frequency response, making further adjustments a lot easier. It removes a lot of repeating work. Is TEOTE an AI plugin? In a sense that AI usually boils down to a curve-fitting task, TEOTE is an AI plugin that performs gain adjustment decisions in a quantity equal to sample rate multiplied by band count per second. However, TEOTE does not use neural networks. It is based on an extremely refined, completely predictable, curve-fitting function. TEOTE is an acronym for That's Easier on the Ear. Features: automatic spectral balancing, selectable processing band count, unlinked stereo processing, multiband gain adjustments meter, stereo and multi-channel processing, internal channel routing, channel grouping, up to 8x oversampling, 64-bit floating point processing, preset manager, Undorito history, AB comparisons, contextual hint messages, all sample rates support, zero processing latency. Let's have a look at the interface. Dynamics. This panel contains parameters that affect plugins' dynamic characteristics. Note that a threshold parameter is not required as this plugin uses a weighted loudness estimation instead, similar to the one defined in the E2 or BS.1770 specification. TEOTE estimates the momentary spectrum, and applies multiband gain adjustments relative to the overall momentary loudness level. The FX parameter specifies the strength of effect applied per band, when the input signal requires adjustments. This parameter is equivalent to a usual dry-wet mix parameter. The required gain change solely depends on the program material relative to the spectral profile. See below. It is a parameterless function. The numerical selector on the FX knob specifies an alternative dynamics envelope mode. In practice, modes above 1 are equivalent to transient emphasis modes. This selection does not change the schematic topology of the plugin, but adjusts, increases, some internal constants of algorithm's dynamics envelope, so may in some cases also require adjustment of the attack, release and high timing parameters, if the effect seems too strong. The boost threshold parameter specifies band's loudness level, relative to the overall loudness level, at which band's gain adjustment stops, and either returns to the unity gain, in the U mode, or is limited, in the L mode. Tuning this parameter is required when working with a highly dynamic or narrowband program material so that both quiet parts and noise floor are not overboosted. Setting this parameter to 0 enables the compression-only mode of operation, useful for narrowband program material. It may be useful to first test the maximal achievable gain change by setting the FX to the maximum, and the boost T to the minimum. If the gain change metering does not go above plus minus 4.5 decibels, it means the program material already follows the spectral profile closely. If the gain change is too large, and rarely crosses zero, it may mean the program material still needs some basic preliminary processing, at least some tilt-like equalizing. After this test, both parameters may be set to less extreme values, to produce a more natural action. In this aspect, when bypassed, TEOTE can be used as a mixing and mastering equalization guide. Note that when analyzing reference tracks this way, you need to fine-tune the slope first, and enable the apply to range switch, see below, since low and high frequency roll-offs of mastered tracks may vary greatly. The base ATC and base RLS parameters specify dynamic adjustments timing. These are similar to timing constants used in compressors and expanders. However, in TEOTE they specify times for the base, 20 Hz, band, with higher bands receiving successively smaller timing constants, relative to the base, subject to the high timing parameter. Depending on the high timing parameter, 20 kHz band may receive as little as 120 of the base band's timing values. That's a very fast compression expanding action. Note that TEOTE uses the same dynamics algorithm dynamics as found in Voxengo compressor's new mode. For both compression and expanding, it is a very natural sounding algorithm. It may be useful to set the base RLS to a value smaller than the base ATC, especially if it is apparent that the plugin overreacts on bass drums. The balance between the base ATC and base RLS parameters affects the peak gain change, in tandem with the FX parameter. Since TEOTE works simultaneously as compressor and expander, the attack and release settings do not react the way they usually react in a compressor. It's useful to perceive these settings as coloration settings. For example, if you want to tame resonances, a lower attack and release setting should be used. And if you would like to boost transients, higher values can be used. Only when the boost T parameter is set to 0, these settings react in a more usual compressor way. The CH link parameter specifies the strength of linking between channels. In a fully unlinked mode, 0, the plugin adjusts all channels independently of each other. It also consumes a lot more CPU resources. Unlinked mode can skew the stereo field information, and may not reach the overall spectral balance goals. In most cases, it is suggested to leave this parameter at 100, or close to 100, as TEOTE even in a fully linked stereo mode does not affect the sound stage adversely. Due to its multi-band processing algorithm, lower values can be used to produce artistic sound stage coloration effects. The P and a switch selects the mode of channel linking, peak or average, RMS. This switch affects stereo material only. At higher channel linking values, it has no effect on mono material. The P mode usually offers heavier sounding basses, while the A mode usually sounds snappy on full stereo masters. To be more specific, peak in the channel linking algorithm means extremum of signals. If the left signal equals right signal, the extremum is same as the average. So, the A mode sound differs only on stereo signals with a lot of side channel information. In this case, the average may be substantially different from the peak. The energetic, balanced, controlled, fluid stable, fluid punch switch selects the overall loudness estimator's response mode. This mode affects both the handling of transients, stability of sound, and overall sonic coloration of the result. While for an untrained ear the difference may not be large, for a trained ear it may be decisive. The difference is most apparent at lower bass ATC and bass RLS settings. The balanced and controlled modes offer more instant loudness estimations, producing a minimal dynamic overreaction, but they may sound a bit too controlled. The fluid modes use a substantially different method of loudness estimation. They usually sound a lot gentler. The mastering switch enables the so-called mastering mode of dynamics processing. It offers a lot gentler gain adjustments, especially in the bass range, and usually reaches only 3/4 of the gain of the non-mastering, feed-forward, mode, so it also requires the FX parameter fine-tuning. Technically speaking, it is a feedback dynamics mode, and only adds a single instruction to the processing topology. However, in practice this mode takes 80% more computing resources on some processors, and it may require lowering of the band count. This mode is best used on full spectrum material that is initially close to the target spectral profile. Spectral profile. This panel displays knobs that control the target spectral profile that TEOTE makes program material follow. TEOTE balances the program material to this profile. Note that the plugin does not apply any filters, so these knobs are not related to filtering of any kind. However, as the spectral profile acts as a reference, if the program material spectrum deviates from the profile, this may result in spectral adjustments that reflect the required spectral profile. The provided set of profile parameters was designed for contemporary music mastering. This includes the slope parameter, which controls the target spectral slope, in decibel per octave, with -4.5 decibels being a de facto standard in contemporary music. This parameter affects the brightness of the result. The low cut and high cut parameters apply -12 or -6 dBocht roll-offs, depending on the cut -6 cut -12 switch, to the profile. These can be also commonly found in contemporary music. The room dip parameter, though not being common, applies a -2.5 decibels, 1 octave wide, bell-shaped dip to the profile. Such dip accounts for usual listener room's acoustics deficiency, where the first offending room mode happens at 130 to 200 Hz, which makes the music sound a bit mushy. This dip can be disengaged by moving it to 20 Hz. The bands parameter adjusts the number of processing bands. This parameter affects both the precision of the processing and the CPU load requirements. For mastering, it is suggested to set this parameter to a higher value, while when processing the individual tracks, lower values can be used. At lower values, the low cut, high cut and room dip parameters may not be followed closely. The band's values below 20 produce a slight -0.4 decibels bass and highest frequency roll-off due to plugin's band splitting design. The algorithm won't be able to detect sharp resonances at lower bands values. However, even at higher bands values, TEOTE mostly performs smoothing of resonances rather than removes them completely. Higher bands values do not always produce better result. Higher values may even produce overly sterile sound, removing too much nuances in the program material. The apply to range switch can be enabled if you would like to apply the effect to a selected range of frequencies only. In this case, the cut parameters will be transformed into the range parameters. When the range low parameter is set to a value higher than the range high parameter, the mid-frequencies processing will be bypassed. If you would like to compare the full spectrum and spectrum range-only performances, it's suggested to use the AB comparison feature of the plugin. Note that in this mode the cut -6 cut 12 switch affects the frequency range roll-off, its width. The flat EQ, loud EQL plus rock switch selects an additional profile setting, which may be useful during mastering. The EQ loud setting applies a 2 to 2.5 decibels, 0.8 to 1 octave wide, boosts to 60, 1.57 K and 9.1 kHz spectrum areas. The EQL Plus Rock additionally applies a boost to 3.4 kHz spectral area, which is often used in rock and metal music. When using these settings, a post equalizer after TEOTE usually becomes unnecessary. These settings are best used for slope values less than -4.2 dBocht. For higher slope values they may be excessive. Note that these profile settings may make the sound a bit thin, so they are not universally applicable. Also note that for these settings to be precise, at least 30 bands processing is required. As this plugin only performs spectral balancing or normalization, it cannot create spectral content, except dynamics processing associated harmonics, especially at lower frequencies. So, for example, if the program material generally lacks the higher frequency content, but mostly contains hi-hat hits, they may be boosted considerably. While statistically the outcome will be balanced, compositionally it may sound like it's filled with hi-hat hits mostly. Similarly, this plugin may not be immediately efficient on bass guitar, that lacks full frequency content, but works well on vocals and drum buses. The low cut and high cut parameters can be used to reduce overreaction on a lack of spectral content. Alternatively, the apply to range mode can be used on a narrowband input signal. Note that this plugin uses analog style band splitting, which produces a slightly non-even, ±0.15 decibels, frequency response and induces a minor phase coloration, dependent on the FX parameter. In such a tremendously dynamic plugin like TEOTE, which features a very fast response at higher frequencies, such approach is desirable in comparison to linear phase band splitting or dynamic equalization, which both may introduce transient artifacts. TEOTE uses the same band splitting technology as Voxengo Sonoformer plugin, which is being used by engineers for more than a decade, without any objections to its sonic qualities. More specifically, TEOTE, like Sonoformer, changes the phase over the spectrum only minimally, approximately for 4 degrees, with the phase shift being close to linear across the audible spectrum, while its dynamic adjustments do not change the phase by itself, but may induce harmonics. On the other hand, usual dynamic equalization may induce both phase shift ringing and harmonics at the same time, depending on the EQ steepness and change timing. Moreover, in TEOTE, if you leave the FX parameter at e.g. 50, it will be only 50% of the full, initially minor, phase coloration. Plugin's phase coloration is so small the full process signal sounds well as just a mix with the dry signal, what the FX parameter does. Level meters. TEOTE features a multiband gain adjustments meter, and the out meter. The display range of the meter can be changed. Note that the gain adjustments meter displays integral per band gain adjustments with 200 millisecond integration time. It may be beneficial to enable the density mode in the plugin settings window to have a somewhat more informative gain metering. The out meter shows plugin's master output level. You may take a look at the out in indicator to see the average gain change taking place, which may be accounted for with the out gain knob. In chain position, this plugin is best placed before the final clipper and/or mastering limiter, and after any equalizing and dynamics processing plugins. However, if the music style requires augmentation of certain frequency bands, 2.5 to 4 kHz boost in metal music, or 60 Hz, 1.5 kHz, and 9 kHz equal loudness boosts, a plain equalizer can be placed right after this plugin. Since TEOTE produces a somewhat balanced spectrum, post-equalizing it becomes an easy task. TEOTE is in no way a complete mastering solution. For best results, it may require a prior static tilt equalizing. Preliminary dynamics processing is, however, less of a requirement, especially if individual tracks in a mix were also balanced with TEOTE. It can be suggested to use a spectrum analyzer like Voxengo Span Plus, tuned to the required spectrum slope, with a longer averaging time, after TEOTE in the chain. Since TEOTE bases its multiband gain adjustments on momentary spectrum, whose correlation to the integrated spectrum greatly depends on the program material and its dynamics, TEOTE may not always reach the target integrated spectral profile. In this case, a correction to the slope parameter, or a preliminary tilt equalizing may be required. To sum up, the most flexible plugin chain looks like this: EQ, preliminary, greater than TEOTE, balancer, straightener, greater than EQ, profiling, greater than limiter. The profiling EQ may be omitted if TEOTE's result sounds satisfying. It is a common question why TEOTE does not offer a way to define more elaborate profiles. The main reason they are not offered is because TEOTE is a multiband processor. It is discrete relative to the required final EQ profile, and may not be precise towards required peak gains. Secondly, TEOTE is not hard precise in applying an integrated EQ profile, as it is precise only relative to a momentary spectrum. Thirdly, fine-tuning a profile is as time-consuming as using an EQ, so there may not be any workflow efficiency gains in such profiles. Well, I'm impressed you are still here. This only means two things: you now know a whole lot about this powerful plugin and you are a professional. Thanks for watching. We would love to have you as a subscriber. Make some outstanding music productions.